All right, where's a good place to start?
Distributing -5 fluids.
Yeah.
I really don't like that you guys say distribute.
Sorry.
At least I get what you mean now.
Yeah.
Multiplying 5 fourths
Expanded.
to the x and the y in the numerator.
Power to a power.
Yes.
Yes,
Yeah.
the power to the power.
All right, what is this going to be then?
That's going to be 5.
5/8.
5.
What about the y?
-10
10
fourths.
minus 10. 8. No.
What?
10, negative
No,
10 fourths.
fourths.
Might as well put it in lowest terms, right?
Yeah.
Like the 2 is going to simplify with the 4 for halves and just leave the 5 alone. How about down here?
0. So do we
Pull out what you can in the
Yeah, so here I can take 2 groups of x out and just leave a 5. So, and then here we can take out 1 group of x, 1 group of y. And leave
2y.
2y. And then we have this y to the 5th.
You did a good job extending that line, by the way.
Okay, what would you do next?
with the x's, make the x squared just x and x. Just
These ones?
yes.
Okay. So maybe just to save rewriting, let's just cancel that and that.
Yep.
Okay, what else?
Try to get the radical out of the denominator.
Okay, sure, we could do that now.
Good
We could, these two make a fraction, so we could work on simplifying those. But let's deal with those radicals right now. Actually, well, let me ask you how you would do that, Lexi, since you proposed that idea.
What idea?
Getting the radicals out of the denominator.
You times it by 2y.
2y? Root 2y?
Root 2y.
Okay. I could do that. What is the power on this y right here?
1.
No, because it's in here.
It's 1/2.
It's 1/2. So we could rewrite it as y to the 1/2, and then we have all these y's with exponentials instead,
Sure.
if you
Yeah.
want. We still have a root 2 that we'll have to deal with, but that might be later on. What if we stick this, since it has a negative exponent, what if we put it down in the denominator too?
Okay.
So I'm going to leave the whole numbers or the constants in their radicals for now.
Oh, well.
But here we have, well, I'll bring down the 5/2 and put it with the 1/5. And then kind of collecting y's over here on this right side. So putting it, what I mean by collecting is putting them all kind of in the same spot so you can see what's going on with them. Okay, what would you do from there? Yeah, let's work on cleaning up the y's. And in the same step, we could do this x subtraction too. But let's definitely work on this. So what do we do with these in the denominator, but the numerator of the denominator? What do we do with those? Yeah, we need to add these two. So 5/2 plus 1/5. How do we do that? What's a good common denominator? Tenths. So what is 5/2 in terms of tenths?
25.
Okay, 25 tenths. And then how about 2 tenths. So we get 27 tenths. How about down here? Let's make these tenths as well so that we can subtract easier. How many? So this is 10 tenths.
And then
5 tenths. Okay, so we have 27 tenths minus 15 tenths. So 12 tenths. So it's, and in terms of our next line, it's going to be down here below the main line. But 12 tenths, is that going to be above this line or below it? You know what? Let's also reduce that. What is 12 tenths reduced?
6/5.
Okay.
Still have a radical.
Yep, we'll deal with that last now.
Okay.
Just because all of this is kind of destructive. I put that in the wrong spot. By the way, because this root 2 is in the denominator of the denominator, where can it go? Into the numerator.
Wait, can you say that again?
This root 2 is in the denominator of the denominator, so it can go back to the numerator.
Okay.
So think of it this way. Let's ignore all the y's maybe and just do x divided by root 5 over root 2. What's the rule for? Yeah, keep, change, and then flip over. So the root 5 kind of stays where it is, but the root 2 came up. If that makes sense. Okay. Let's do these x's. How many eighths is this x?
8.
That's 8 eighths. So x to the 5/8 over x to the 8/8 becomes what?
3/8.
Yep, x to the negative 3/8. Trying to put this as a map, so not a map. Like some explanation of how we got to the end.
Not just the end.
Okay, so that goes down to the denominator. Okay? And I think that's all, right? Okay, what do we do from here? Oh, I need my root 5.
Yeah.
Okay.
Okay, how about now?
Now we need to root 5 out of the
Yeah, and technically we have the x has a radical. If we wrote it in radical form, it would be the 8th root, and the y would be the 5th root down there. So we've seen problems where we have just rational exponents in the denominator, right? And we never worried about clearing those. So I think we'll run this problem that way. And what do we do with this root 5 to get rid of it? Alright, so final, we can combine the 2 and the 5 underneath the radical since they're the same index. And we'll have x to the 3/8, y to the 6/5. Tell me about that.
Wait, which point, sorry.
The y to the 6/5. If that was written in radical form, what would we do? Yeah, we'd pull out a y out of the radical. So it would be y 5th root of y. We don't need to do that here because that'll just introduce the radical back to the denominator. And we'll have to multiply it all. I think this is good enough for this one. How'd that go?
I think I just freaked out when I see big columns.
Okay. How'd the homework go?
Good.
Great.
Great, nice. Let's check it. So 22, 30.25. 24 was 81. 26, 338 x squared. 28, 81 x to the 4th. These are y equals, I haven't said that, but 30, x is 5/4 and x is 3. 32, x is 7. Any of those you'd like to do?
Oh.
32, okay.
I know. I was like, I don't know. Well, I was in shelter in place. And I didn't know.
If we had, if I had to go to band this year, just play competitions.
Yeah. Well, how did you get the competition?
Okay. So we just need to square root both sides to get rid of the radical. In this case, there's nothing tricky or funny going on about this. Not square root, square. Come on, Lord. Okay, what happens on the right side when we square that? 56 minus x. Okay, and then this is a quadratic with a bx term, so set it equal to 0.
Why did I not?
Why did I do that?
I don't even know what.
Factor, you can write out the star. Okay, then we need to make sure what is true about those. Work how? Yeah, so if we plug these back in here, does it make one of these two side? Well, actually, the left side, can it be negative? Yeah, no worries there. So does it make the radicand, negative? So are either of these an issue? No, they're both fine. All right, any others? So do you hear me? We're good? Cool. Grab your notes. Let's do, well, let me show you what we need to write in here. Do you need to do any more of those before we look at the next version? Like, do you want to do another one? Yeah?
Sure, why not?
Okay, 3 minutes. Just this one with the star. Yeah.
It's because I'm a student.
So remember when you expand this binomial, well, first of all, you have to square the whole side because we're squaring the whole right side. So x plus 2 on the right side. But when we expand this out, it's whole group times whole group. So we'll get x squared plus 4x, not 2. Why am I writing in this?
If it was like plus 5 on the left.
X squared
on the right
plus
side,
4x plus 4. There we go. Now what?
if outside of the radical, if there was another plus 5, would you just do x squared and then 2 squared on the other side? Oh,
Nope.
just kidding.
Yeah.
Okay.
Square the whole thing.
Okay.
But then you're not squaring the whole thing on the right.
Yeah, if you do this.
Subtract the 5 over.
Yeah, you would. But we're going to run into ones where you have to square a big thing like this. But yeah, in that case, Jazzy,
Yeah.
you would just subtract the 5 over and combine it. But if there was a situation where that didn't help, you would square this whole thing. Alright. Get all your like terms together on this, or whichever side you like. Factor. Okay. Does negative 2 work? Yeah, it makes this 0, which is fine. Does negative 1 work? You do need to indicate that you checked for both. Okay?
I just wrote x equals -1 and -2 and circled them.
I'd like you to say either something like both work or no extraneous or something, just so I know that you checked. And it wasn't just like you got lucky that it worked out. Alright, let's look at this kind briefly. Like really briefly. If you want, we can just do it in your notes. That one's kind of easy though. Let's see if we have a better one. Yeah. Before we put this one in there, let me ask you about the one I said was easy. What would you do to solve that? So no, you wouldn't want to, what you guys call distribute the 5 halves. You wouldn't. Just take the whole side to the reciprocal power. Okay, so that side stays 1, and now this side is, there's no rational exponent.
I see.
I
Okay?
thought we were doing.
Because either way, you'll still.
Take it to the reciprocal power. Yeah.
Did you make these notes packets? Like, did you like get them like on a Word doc or something?
Probably. Yeah, why?
I was just wondering if all the other math teachers use these. They're nice.
No, just as far as I know, it's just me. I'm glad you like them. Thanks for telling me that.
Yeah. I like them.
Yeah, no, my
Some people don't.
friends.
Well, those some people can deal and do their own notes.
Yeah, that's what I think too. But like Cooper uses a notebook and so does Tom, which is good.
Oh, that's
Well,
fine.
like,
The
yeah,
only
if
reason I
you
do it
like
is
that
because it gives me more
And you
space
can
is
keep
all.
all your stuff together, that's totally okay. But I like to do mine by dates. So
Yeah,
Me too. And the colors help.
that's good. Glad to hear that too.
Yeah.
All right, so we're just taking this to the reciprocal power. I guess we should say before I write that on, we have to do this to both sides. Yeah. In other words, just don't forget to do that. You can't just do one side. Okay. This one I guess isn't that big a deal either. But what is x minus 2 cubed to the 2/3?
6.
The 3's can cancel out and you get 2 of them.
It's just 2, right? The 3's
Yeah.
cancel. So this becomes x minus 2 squared. And that becomes x squared minus 4x plus 4. And then that's x squared minus 5x minus 14, which factors to x minus 7 times x plus 2, which gives x equals 7 and x equals negative 2. Do either of those have an issue? No. Oh.
What if I just go like E dot, like this abbreviate?
What are you abbreviating?
Word?
Two one-syllable words?
Yeah.
A lot to write out.
Oh, brother. Didn't you just tell me you're taking an AP lane test tomorrow?
Yeah, so I can't fry my brain today.
Uh-huh. Alright, so those kind, I'm not going to do much with those. Just know that's how you solve them. You might come across it at some point, but. Any questions on it?
Nope.
All goodies.
Okay. So let's look at this final solving kind, which is that one. So what's different about it? I kind of mentioned it yesterday, but what do you notice right now? Two radicals. So do you remember what I said about how to work with these?
No.
Oh, are we putting this one on our next?
Yeah. If it was just one radical, what would you do?
The same thing.
You would just do the whole square thingy.
Yep.
Or cube or fourth or whatever you feel like you got.
Is this 2 or more radicals or just 2?
Yeah, I suppose it could be 2 or more. Now, I told you yesterday we're only going to be doing square roots. It's not because you have to. It's just
The only way it works.
so it get, huh?
The only way it works.
Well, it just would be a lot of work if you were doing cubes or fourths. Like, cause think about expanding out a cube, right? It creates a lot of terms.
I think it's just less of
You just combine the radicals with the same things.
Yikes, no.
Just kidding then.
Can I combine those two?
No, because they're
Yeah.
the same radicals.
Okay.
Just kidding.
It only has the same impact.
They do have the same index, but not the same radicand.
The same radical.
So pick one and get it by itself. Here's advice though. Start with the uglier one. If there is one. Like sometimes you can't really decide, so who cares? But if there is an obviously worse one, start with it.
There is no numbers at
That was just so weird.
Yeah, you have.
Just right.
So how do we get, I'm going to call the one with 2 terms the uglier one. How do we get it by itself?
Square.
Seriously, guys.
Yeah.
Get it by itself.
Add
Add
Is it?
Yeah.
Oh,
Oh, we're
it
starting
was
blank.
not just me, okay?
I know, I said guys.
So,
Does that root 3 plus 2x? Can I combine those underneath the radical? So it's just 3 plus root 2x, or you can reverse the order, but, okay? Alright. Now what do you think we do?
G.
What was I? No, it's
Big
I'm telepathic.
I can't tell my phone is at
It's already square rooted. Did you say square root?
That's it's good.
So get rid of the lone radical. In this case by squaring. If that was cube root, then you'd have to cube the right side. Do you see how that would be a lot?
Yeah.
Okay. So I'm going to say specifically by squaring, just know that that's not the only problem that ever exists in the world. Let's put a note here. This was an issue yesterday, so maybe add some emphasis there. Like 4 exclamations. Don't miss this,
How do you say
Lexi,
that
like
word?
that.
I feel very
How do you say that word? Because I say.
You're
Just
not
say it.
attacked.
I'm not attacked.
Okay. Say that word.
That word.
No,
Extreme.
no, exclamation point.
Exclamation point.
I
That's 2 words, by the way.
I've always said it wrong.
That's 2
I was
words.
just wanting you to say
Alright.
exclamation.
What happens on the left side?
It becomes X plus.
Okay, over here, we need to do 3 plus root 2x times itself.
Oh boy.
I
That sounds
So we're distributing with a radical, no big deal. We get 9 plus what? 6 root 2x plus 2x. Okay? Everybody understand where that came from?
Yeah.
Okay. So all we did was just distribute. Okay. All right, next step.
And then
What do you think we do next?
get the other radical.
Hey, good job.
Let's
What did you say?
I said let's go.
Yeah, it was awesome. Okay, there is one thing that we need to clarify. Everybody look here before you keep writing. Do you see how this next radical has a 6?
Yeah.
Do we need to get that off of there?
Yeah.
No.
No.
It would be pretty messy if you did that. I'll show you why, but so say leave any coefficients on it.
Okay.
Any coefficient. We only have one. Coefficient on it.
I just want
I'm so glad that it's done.
Okay, so we get negative x on the left side.
Do we nurse here?
So negative x, the 9's cancel, equals 6 root 2x.
That's so much more.
Yeah, well, in this one it is. It's not always going to be. But look what would be, don't change yours. We're going to pick up from here. But if I put this 6 under here, now we're squaring that. Definitely you won't always cancel your constant, or you'll have other terms. And so now you have, like, what if it was negative x plus, I don't know, 13. And now both things have a 6 underneath, and we're having to square the whole thing. You see how that would get ugly really fast?
Yeah.
Unnecessarily. So don't do it. Leave those coefficients with the radical. Alright, square both sides again. So it's just kind of a repeat of steps 1 and 2.
So then the left turns into x.
No. And I think it's worth emphasizing yet again. Let's get rid of this stuff. That we need to square both entire sides. So this becomes x squared. Over here on the right, what happens?
well,
36 times 2.
Okay, well, look what's going to happen. 6 times 6, there's our 36. So this becomes 72x. Okay? Guys, there's lots of places you could blow this, right?
Isn't the same thing as just
No. Is negative 2 times negative 2 2?
whoa. What?
Yes.
Okay. What is negative 2 times negative 2? 4. You're good?
Yeah.
How do we solve this guy?
Subtract 72.
Why? Why don't we just divide by x on both sides?
Because
Good job. Guys, if you don't see that, you really need to make sure you either ask me or lock it in from here. But like he just said, if we just divide x off of both sides and we get x equals 72, we're missing a whole root, right? This is a quadratic. So how do we solve this kind? This is the GCF kind. So x times x minus 72 So what's the first x? And the other one is 72. Now, we still have to go check for extraneous. Does anything have an issue? Okay, we got a little behind on our steps, so solve for x as usual. As usual. And then check for extraneous. But both work. Oh, and don't abbreviate that.
Man. I'll cover the letters, covering mine.
BW, is that what you would say?
Yeah.
So, what do you think of that? It's kind of like just do it twice, right? But like I said, you could mess this up, I think, if you're not careful. So write it out. You could also mess this kind of stuff up, so be careful with that and write it out. Let's have you try one. Do we have any good ones? Maybe just have some on your paper. They're all kind of 38 looks, it's a little better. Well, actually all three of those. Do you want to do one on the board or just work on the ones on the paper? Okay, so you're going to do 35 to 38 right now. Yeah.
No, we should have done 38.
How many lines is it?
Oh, I might have missed this. I was confused after this.
Right, so we'll do 36, and you can finish these up for tomorrow. Then we'll check the rest. Okay, so in our notes we said get the more ugly one by itself, but in this case they're the same. So just pick one of them.
Plus,
I'll probably just get this one by itself, so
yeah.
you know I don't have to move a bunch of stuff around. Okay, now we're ready to square both entire sides. So square, and use parentheses to help remind you of that maybe. So left side is nice, it just takes away the square root, but this side we have to expand.
Yep.
And like I said, this is where you can mess this up. So write it out to make sure that you don't miss a term. Okay, so we'll get 4, and then 2 roots plus 2 root. Maybe I'll write it out this time. And then, how about the end?
It just turns into x.
Yeah. So
But
sorry that ran
you
out
have
of
to
room.
put that in parentheses.
I didn't mean to write that square root. Okay, so he said you have to put that x minus 5 in parentheses. You don't.
Yeah.
Because we're squaring something. Like think if this was 2 minus, maybe the original problem said plus root x minus 5, so then we subtract it and it's minus. But what's still going to be true when we multiply it by itself?
It's positive.
It's always going to be positive, right? Because we're squaring it, so you don't need to worry about parentheses. Okay, so we can combine the 4 and the negative 5, and of course the x stays out front. So we get x minus 1 plus 4 root x minus 5. Everybody good on that?
Yeah.
So maybe I'll just bring this down here.
Nice.
Okay, now what?
Where's the x minus
We
1
get
from?
the
Well, we have this x, and then 4 minus 5 is negative 1.
Ah, yes, okay, yeah.
Okay, so we're going to combine our like terms. This one is nice because the x's cancel.
Okay.
They won't always.
Yeah, I did that. Oh darn.
Okay, now what?
Now you have to square both sides.
Yeah. So square root both sides again.
Oh, sorry. Yeah, I did.
And we'll get 49 on the left. How about this? What does it become?
I got
16.
16.
X.
Is it like this?
No.
I didn't have it
Yes, it is. Because you have to have. Okay, now I'm confused. I feel like it is. Ah, I actually did that.
like perfect. So much.
In other words, the squared gets rid of the square root, but then the whatever's out front gets multiplied by both of those roots. Okay? So be careful with that. Anyway, add 80. What is 80? That's 129, I think.
Oh,
You're joking.
I minus the 80.
Great, so I
But other than that, I got it.
Take her phone
Yeah, whose is that?
It's not mine.
Needs to be turned off in the back, right?
away.
There's a box over there calling your name.
Or put it in your backpack. All right, any questions on that?
Friday.
Yes.
I might cry. You do. You have to write FRQs on how to solve the problem. No one's taking that.
All right, so back to functions again. We'll see how much we can get into this before we shift to review. How many days do you think you need? Your test will be on Tuesday.
As
All
much
of
as I can.
Two.
Yeah.
I agree.
2 study days.
5 to 6.
In class is what I meant.
Yep.
Because you guys
Yeah,
have the
Friday.
weekend, you can do that too.
I'd say
Friday
6 to
was
7.
That is very true. That is
I
very
feel
true.
Well,
So 2 class periods?
But
Five,
Friday,
Two class
yeah.
periods.
I
Yes.
think
At
the
least.
weekend is best because Friday we can remember all the
20,
stuff
30,
and
40,
study it
50.
more. Not the stuff we didn't remember, and then Monday we can come back and just make sure we got everything right.
Okay.
That's true. They don't.
And then
So we'll
Tuesday.
do, maybe we'll do a little bit tomorrow and then Friday and then, like you said, pick up with Monday with any questions you have.
Yeah.
And then Tuesday's our final.
Yeah.
And Wednesday.
Are we getting a review thing?
Yeah.
A review paper?
Yeah.
Wednesday we're having the breakfast thing. Are we still doing that?
We haven't talked about it. So I
Depends
don't
on other people.
Thursday, no, Wednesday's our last day. Could do it on like Wednesday, before the last day.
Yeah. Do we want to do that?
Yeah.
No, we talked about doing that last time and like everyone's gonna want to talk. We're gonna go and talk.
What's that?
Okay, so review that definition. We've written it before.
A relation.
What all are we doing?
Oh, we got
Friday? Just review.
Friday's my birthday.
We could do review and food.
Oh, well, we wanted to do food and then the games outside. That's what we talked about. Do we still
The
want
last
that?
day?
Yeah.
Yeah, you had, wasn't it you had a game that you were gonna bring?
Yeah, you were gonna
The
bring-
poetry for New Year's proposed.
Yeah, that.
Yeah, that.
That sounds like something for.
Okay, so a
someone
function
else.
is a relation that assigns exactly one output to each input, just reminding you of the vertical line test. That's a visual thing, not a, you can't check with a vertical line unless you're looking at a graph.
One input.
So, what does the word composite mean to you, or composition?
Right.
Writing, okay. Money?
Oh, yeah, no, that's
Like a composite, like put some in. Oh wait, no.
Yeah, I mean, that's where you see that word composition notebook.
Charts.
Well, composition or composite.
Composition, I think, of like putting something together.
Yeah, I
Okay.
think it's.
Putting something together, that's pretty descriptive of what we're going to do. So, in terms of functions, a composite function is a it's putting one into another, or maybe one inside of one inside of another. I mean, you can compose lots of functions. We'll probably do like 2 or 3. No. Well, what do you mean?
Like you're taking one and using the other.
Yeah. Well, if you're thinking like solving a system, not quite, but it's kind of. All right. So what you're gonna see a new notation, and people end up calling that notation fog and goff, but it's not that. So I don't want you to be those people who say that, because that's not what it is.
Maybe like the sin instead of sign.
Yeah, that.
Sin, cough, tan.
Yeah.
With disappointment.
All right. All right. Okay, so we're going to learn 2 different ways of seeing this. And those of you going on, which is I think everyone, you're definitely going to see this one more. Actually, let me define this and then I'll tell you which one you'll see more. Here's an easy way to think of this. A function inside of another function. That is what a composite function means. And it could be more than 2. So we could have one inside of another inside of another. Okay?
Okay. Oh my god. Every time.
Notation. So we're using function notation, of course. So this is the more common version, definitely for you going on to higher level math. There we go. Okay, so you'll definitely see this one. Can you?
Yeah, I'm sorry.
The other one is, this is why it's called f of g, or excuse me, fog, is because it looks like fog, only that's a little circle in between them. It's like the multiplication dot, but it's open and bigger. Okay? Both of these, you don't say fog, both say f of g of x. Okay, so some function f, we plug whatever function g in for each x. Okay? So we say that, and here's what it means. I'm just going to keep on going in this box. And this, what I'm about to write, is pretty critical for understanding how these work. So it means plug g of x in for each x in f of x.
In the equation, where you find it, plug
So we'll just put an example right here. Let's say f of x is some polynomial. So 3x squared plus 2x plus 7. And g of x, if you have colors for this, it might be kind of helpful. Let's say g of x is, I don't know, x minus 3. These are kind of simple ones, okay? So what is f of g of x? F of g of x So what did we just write? Plug what?
Plug x minus 3 in for x.
Okay. So here's how I want you to do this. It makes it much easier. Everybody pause your writing and just watch for a second. I want you to write whichever one is the outside function, so in this case f. I want you to write it with parentheses around all the x's, like that. And then go back and plug in whatever you're, like in this case, plugging in g of x into those parentheses. Okay? Now, is that done? Or can we expand it out and combine like terms and stuff, right?
Yeah.
Okay? But conceptually, this is good enough for now. Now expand and combine like terms. Okay, let's take this same two functions and do g of f of x. Okay? Did someone say what? G of f?
Well,
Okay.
Yeah.
So is that golf?
Yeah, so that would be Goff, right? Well, I guess just up here, let's just put it out to the side. Or in reverse, g of f of x, g of f of x. Okay? So for actually, let's don't complicate this. Or let's do it this way. Or g of f of x. What would g of f of x be? Okay, remember you're going to write g with parentheses and plug in f, which I did not leave enough room in. Have you ever heard somebody order coffee with room?
Wait, what?
No. Why do they do that?
So they can take it and put what they want in there. Like maybe they put their own
yeah.
cream or their own sugar or whatever. Leave room. Okay, that's the point. Leave room for the other function to go in. So use parentheses around it.
Okay, we can do that all in the right one.
So again, the letters notation without the circle is more common.
Oh, okay.
Okay.
It kind of goes with orange and green. Like light green.
So here's kind of a visual of what is actually happening if we use numbers. So this is f of g. So you'd plug in x to g first. Even though, like, let me write it bigger so you can see it. F of g of x. If I said what is f of g of 2, where would you stick the 2 first?
G.
Yeah, you're going to stick the 2 into g. G does its thing on 2. Then that result gets plugged into f. And f does its thing on that result. Okay? So if you don't need to write this because we'll put an example in here. But if I said f of g of 2 here, I would plug 2 into g. So 2 minus 3, 2 minus 3. And then that result gets plugged into the green one, which is f. And we do f of negative 1. Okay? Does that make sense how this actually does the output? Okay. Do you feel like you need a basic one? Do you want to just see another example? Sure.
No, it's just.
Why?
If you want me to do colors, let me know.
No, it's alright.
Okay. So we want to know what f of g of x is. Oh, by the way, did you notice that the parentheses kind of got smaller on the inside? So it's easier to keep track of. Okay, so what is f of g of x?
4 and then parentheses 2x plus 3 minus 5.
Okay, so we left room for g to be plugged in. Okay, now we simplify, so this will be 8x plus 12 minus 5, or 8x plus 7. That is f of g of x. Okay? And this is just in symbolic form, there's no evaluating, right? So if I said what is f of g of negative 5?
You would just plug in negative 5.
Okay, you could plug negative 5 into g. So what is g of negative 5?
Negative 10.
13.
No, 7.
2 times negative 5 plus 3 is negative 7. And now you're going to do f of negative 7. So we take that into f of x. Okay?
So that's 5.
Or you could have plugged it in here. Plug negative 5 for x, which is negative 40, plus 7 is negative 33. But sometimes you don't want to have to do the symbolic form if you're only asked for evaluating at a single point. Okay? So how does that seem?
Good.